Hey everybody, so here is tutorial 3 part 2 where we're going to continue where we left off from tutorial 3 part 1. The first thing I want to mention something within tutorial 3 part 1 before we move on is if you take a look at these spheres, you'll see they have a very coarse edge to them. They're not very smooth spheres. And that can be good if you're rendering a huge number of objects, because the higher the dimensionality of an object, the harder it's going to be for the computer to render it. But in this case, we only have 20 objects, so we might as well make smooth-edged spheres. So we can target 0, target all the spheres, and set their dim to a nice high dim value, like 50 by 50. And that's going to give us smoother edged spheres. So if we zoom in now, we see that we're getting a much nicer, smoother edge. But if we're going to be going in really close, we can still see that this is not entirely round. Then we can go up to a very high dimensionality, like 100 by 100, to give us a very, very smooth edge on the sphere. But again, this high dimensionality is going to be harder for the computer to render, so we don't necessarily want to go there. And we only need high dimensionality if we're dealing with curved shapes. If we're dealing with things like cubes, we can work with very low dimensionality. I can take this down to dim 10 by 10, which looks terrible on spheres, but looks fine on cubes. Something we can do with the tools that we have right now is we can make a little city. We can take the rectangles that we're working with right now and render them as suggestions of buildings. How would we go about doing that? Well, firstly, our color palette is not right for an urban setting. So why don't we just make a simple change here and make these, instead of being all different colors, we'll make them all shades of gray. That's a very straightforward thing to do, because right now we're generating 3 random values here representing red, green, and blue, and we are sending the color message. And here it's a little bit clearer if we use the $1, $2, $3. We're sending these 3 random values to all 20 of our shapes, where the first value represents red, the second value represents green, the third value represents blue. Well, shades of gray are simply colors where the red value, the green value, and the blue value are the same. So in order to make this gray, all we need to do is say, take the first value of the 3 and send it to red, green, and blue, and we're going to get all shades of gray. And if you forget that that's how shades of gray are made, that's an easy concept to get back to. If you think about the fact that black is 0, 0, 0, white is 1, 1, 1, halfway between black and white is gray, 0.5, 0.5, 0.5. If you make that darker, you move towards 0, 0.2, 0.2, 0.2, that's going to be a dark gray. If you move towards white, that's going to be higher values, 0.9, 0.9, 0.9 is going to be a bright gray. So whenever it's a gray, your red, green, and blue values are identical. And what we can do here, since we're only using $1, we actually don't need a jit.noise 3. We now only need a jit.noise 1. So there we've just simplified this to give us arrangements of shades of gray for our building colors. That's fun. I'm going to just take this whole structure and encapsulate it so it gets out of our way, and I'll call it building color. And for those of you who are scared about encapsulation, the only trouble you can get yourself into with encapsulation right now is if you encapsulate a jit.gl.grid shape and separate it from its jit.gl.material. These two need to be in the encapsulation together. Otherwise, I don't think there's any way an encapsulation can break your patch. So don't worry about encapsulating. Just encapsulate, because you're going to need it. Your screen landscape is going to become more and more precious to you as your patches become more complicated. Okay, so how can we make these all stand up vertically like buildings? Well, first of all, let's take a look at how we're scaling them at the moment. We're scaling them randomly, but notice they're long rectangles, which means we must be doing some kind of math on the random numbers, because the random numbers are going to be proportional, so they should give us squat rectangles closer to cubes. These long rectangles mean we're doing something in the jit.gen here. So let's open up the jit.gen and see what it is. And here we can see, aha, we're stretching them out 3 times on the x dimension 0.3 on the y and 0.3 on the z. And that's a scale. So we're taking the random values coming in, stretching them on the x, and squashing them on the y and z. And then we're biasing them, meaning we're creating a minimum size. We're adding some base amount to all of them. We can hold on to that bias. That's not a bad thing. But for the scaling, we want our buildings to be tall. So why don't we do something like 1, 5, 1, meaning we're going to accept the random value that's coming in on the x-axis, the width of the building, and multiply it by 1, meaning keep it the same. But we're going to make our buildings tall. We'll multiply them by 5, or heck, why don't we even try 10 on the y dimension, and then 1 on the z dimension. So we'll accept the values coming in, and then we're going to add, let's bias them by 0.5. And these are just, values to try, values to play with. If they don't work out, we just try different values. So let's close our jit.gen. These are much more building-like buildings. Maybe 10 was too much. We'll go back into this jit.gen and just say 5. Let's see what we get here. These look considerably more building-like. Now there's still a couple of things. One, their position is not right, and their rotation is not right. So since they're buildings, they don't actually need to be acted on by forces, so we can make them kinematic. We want to rotate them so that they're all standing upright. So rotate XYZ 0, 0, 0. There. So physics instructions sent to the physics input, and dimensionality and shape instructions sent to the grid shape input. Now we're looking at something that's more like a city. And if I reset my handle and zoom out a bit, I can see, okay, I'm getting something somewhat building-like there. And in terms of the random positioning, we can see that things are too close together. So we'll go back into our jit.gen and we'll scale them differently on different axes. We can spread them out quite widely on the x dimension. We want them all to sit at 0 on the y dimension because they're buildings, so none of them should be floating above the ground. None of them should be totally underground. So we're spreading them out on the x. We're not spreading them out on the y. In fact, we're zeroing the y. And we're spreading them out on the z to make a sort of a city block. And we're starting with our bias of 0.05 so that our random values coming in are between 0 and 1. We're biasing them by 0.5 so that they're in a range from minus 0.5 to 0.5, so that when we scale them, we're getting negative values and positive values. Still too crunched. Let's go in there and try doubling that. That's better. Let's make it even a little bit bigger. Yes, now we're getting something that looks much more like a city block. Yeah, great. Now, we see that there's one obvious problem with our city block here, which is the buildings look good on the top, but then they're kind of mirrored on the bottom because they're being scaled from the center. And there's a number of ways to solve that. Some are more complicated than others. I'll show you the simple way to solve that, which is just to make some ground, some street level. And that solves our problem immediately. Now our city is nicely sitting on the ground. And if we look underneath, we'll see there's sort of a mirror city underneath the ground. But that doesn't matter. As long as we're only seeing it from the top, it looks like these are all buildings that are sitting on the ground. We can put a jit.material here so the ground has some reflectivity to it, and reset. And oh, what happened to it? Well, our camera is at position Y0. So when we reset our handle, we're actually inside this cube that we just made. That's the floor, so we can't see anything. And here I'll show you, if I just delete that, we're looking at our buildings. But if I put it back, we're actually inside this floor we just made. Not a great place to be. So let's just move our camera position up to say like 10 meters above ground level. Yeah, and now, we've got a vantage point on our new city, and every time we We can randomize the colors of our buildings, we can randomize the positions of our buildings, and we can randomize the scale of our buildings. Cool. And we can also make a lot more buildings. This is one of the nice things about, once you've created a structure like this, you're like, this is great, I love it, but I wish I had 50 buildings. Well, boom. Now, we're only seeing 20 buildings here because our 50 buildings are only being moved into 20 positions and 20 scales. So we can move them into 50 different positions. And you can see the ones that haven't been scaled yet. So we need to move them into 50 different scales, and a bunch of them are red, but assuming we want them all to fit in with this scheme, we'll want 50 different shades of gray as well. We could write a book about that. If we save this and close it and reopen it, turn the world back on, we can generate our city very easily. And then anything that we, any multiple clicks we have to do, just stick the button on those so we don't have to do the multiple clicks. And you can always test this out. Save, close, reopen, and there's our city, and every time we click, our city's going to re-randomize. Now, you don't have to make a city. You can make mountains, you can make planets, you can make stars, you can make mad scientist laboratories, you can make what interests you. A city is an easy way to demonstrate to you that these tools are flexible for creating a bunch of different stuff. So what I'd like to do now is take our cube, which is still here, kind of buried in the middle of the city, and look at changing and manipulating that a bit. Before I do that, I'm just going to skip back and do a little encapsulation here. And make sure that these all still work. I can scale my buildings, I can position my buildings, and I can change the color of my buildings. That's great. What can we do with our cube that is actually now hidden by our city in the center there? Well, we can change its position. We can give it a position message. Let's just move it where we can see it. 5 meters above the ground, and now we can see our cube, and that's cool. And we should, even if it's going to be a kinematic object, we should make this a physics object. So we'll do a jit.fizz.body at kinematic 1, and we'll actually position that. And this is also at scale 2 because this scale gets overridden, and it's also at shape cube because the scale, the shape needs to be in both the Fizz body and the grid shape. Connect that up, position it, and now we have a kinematic version of our cube. So let's look at how we would position that in real time. Well, we have a position message here. We can make that position message changeable by using the changeable arguments, $1, $2, $3. And we have a new user interface object that will allow us to change all three of those changeable objects. It is called the multi-slider. So you type multislider, and if you just start typing, it'll fill it in for you, multi-slider. Stretch this out so it's wide, and we have to set some parameters of this multi-slider so that it can be used the way we want it to. So I'm going to introduce a new part of the Max interface, which is this letter I right here, the inspector, which is going to let us change things about the multi-slider. So with only the multi-slider selected, click the I, and here's a bunch of attributes of this multi-slider. So going down, we'll start at the bottom. We want 3 sliders, because we're going to be changing the position of the cube. and we want to range from, let's say, -5 to 5. 5 meters to the left all the way to 5 meters to the right. So 3 sliders from -5 to 5. We want continuous data output, so we want to check that box for continuous data output. And as a slider style, we want bar sliders. And then up top, we want alternating candy cane, 3 colors, and also orientation horizontal. And then we can choose the 3 colors here. They're set by default as this white, blue, and red. I like to set them to red, green, and blue so that you can use this same slider for a color slider later. Just to review one more time, alternating candy cane, 3, orientation horizontal, set your 3 candy cane colors to whatever you want. Number of sliders, 3. Range, -5 to 5. Continuous data output is checked. And slider style is bar. And the rest of the values will be set correctly by default. And this gives us a multi-slider, and we can just hook this up to our position 1, 2, 3 message, and we are now moving our cube from -5 to 5, from -5 to 5 on the y-axis, and from -5 to 5 on the z-axis. And if that's not enough for us, we can go back in here to our inspector and change this range, or there's a nice message that does this for it. It's set min max, and we can say -10 to 10 and send that message to the multi-slider, and now it gives us a 10 meter range, which is nice. And with the set min max message, after you've sent it, you can actually delete the message. It will, the multi-slider will retain those values. Another useful message to have is a 000 message, which just allows you to reset your slider to 0. I'll show you one other thing, which is kind of a power user trick, but might be handy with something like this that has so many settings that you need to set. Click on the object and go down here to, there's a paperclip with a plus that says Save Snippet. Click on that, and you can give this a name, multi-slider, 3 sliders, whatever you want to call it is fine. It says Snippet Saved. Now, anytime you need one of these with those exact settings in place, you can go over here to this paperclip and start to type and see it says multi-slider 3 sliders. Double click it, and it makes one for you with exactly those settings. And you can use this for anything. Anything you want to reuse, you can highlight it, save the snippet, and then whenever you want to, go back and recall the snippet. And as you can see, I have tons and tons of snippets saved, so that all the stuff I use on a regular basis is there for me. And there's also tons of built-in snippets too. And of course, the other way, if you just need to make another one of these, is to Command-C copy, Command-V paste, and that'll duplicate it as well. But the snippet is handy if you're working in a blank patch. So this is really great. I can now move my shape around interactively, which is something we haven't been able to do before. If you want to save a value, find a position that you like there, I want to be able to get back to that position. You can use the right inlet of a message box to create a button that has these values in it. So now when I adjust this, see the values are saved in there. If I disconnect this message box, I can use this message box as a button going into the multi-slider to get me back to those values that I want. And we can do it again. We can take another message box, use the right inlet of the message box, find another location that we like, and disconnect it, put it over here, and now that becomes a button to take us to another position. So we have this position that we like and that position that we like in 0. Let's look for a moment at transforming this cube into a sphere, which we also need to change in its Fizz body. And notice that when I change what's inside this Fizz body, my sphere disappears. That's because it went back to position 0, 0, 0. So now I can use one of these buttons to put it back in the position that I want it to. Why did it go back to 0, 0, 0? Because when you change the typed in arguments of an object, the object will reset itself. So let's make this a planet. Make it a striped planet like Jupiter. So instead of making 3 by 3, I'm going to make 1 by 12, and that's going to give me stripes. My stripes are going the wrong way, so I'll try and switch it around. 12 by 1. That's not going to work. That's going to give me a beach ball. All right, so I had the stripes right the first time. Why don't I just rotate X, Y, Z. Rotate this on its x-axis by 90 degrees. It disappeared again. I need to reset the position, and now I have a stripy planet. Wonderful. Nice stripy planet. My stripes are hard-edged because of this. This matrix is scaling up the resolution. If I take this out, I'll get smooth-edged stripes. And if I want to sort of split the difference and not have them be that smooth, I could, for instance, knock this resolution down, maybe 10 by 30. Let's see what that looks like. Okay, so those are nice softer edge stripes. So I'm generating a 1 by 12 matrix of colors, but then I'm stretching it over a larger matrix to get smooth gradient transitions of color. I'm not liking any of these color combinations. So I'm going to do a little bit of additional work here to get some nicer looking colors. I am going to add a jit.gen and do a little bit of processing on this color matrix in the jit.gen. I could say multiply and take out all the reds. Maybe this is a blue-green planet. So I'll say vec 0, 1, 1, meaning multiply red by 0, which will give me all zeros, multiply green by 1, and multiply blue by 1. And this is our blue-green planet. That's okay. I'm still not excited by it. I'll go into the jit.gen and say, all right, what if I wanted to make it like a pink and orange and yellow planet? Well, then I could add red to this. So here I'm stripping out the red, so the red is always 0, and then adding a fixed value of 1 for the red, so the red is always maximum. And the reason why I'm doing it in 2 steps like this is so that I don't get values over 1 for the red. That's nice. Pinks and whites and yellows. That's a great looking planet. The other way to handle this same thing, if this is a little bit confusing to you, would be to introduce a new object and say, I want to add 1 to my red, so my red is always at least 1, and add nothing to my green and nothing to my blue. But in that case, I'm going to get values for red that are greater than 1, which are not technically legal. So I can use clip, say clip 0, 1. It'll just clip all my values between 0 and 1. So any red values that this takes over 1 will be clipped to 1. And I'll get exactly the same result. The only object that accepts color values greater than 1 is jit.gl.light, where you can send color values greater than 1. That will just make the light brighter and brighter. But objects should not be colored outside the 0 to 1 range, so just use clip 0, 1 if you want to keep everything within the range. So you can actually write your matrix to disk just by attaching the write message and clicking it, and it'll call up a save dialog, and you can call it planet colors. If you save it as planet colors, then you can read it back with the read message, planet colors. Now when you write, it wants to call it matrix.jfx. Just delete that whole thing and call it what you want to, because when it saves it, it's going to stick .jit at the end. When you read back your colors, you can read planet_colors, and it will read those colors back in. Then we actually are going to need a button in addition, because we won't see the changes. It'll read the colors in, but they won't actually be sent out of the matrix. So we'll generate some different arrangement here, and then get back to the arrangement we like. Having to hit this button is an unfortunate extra step. You can actually use the right outlet of jit.matrix to hit that button for you. So when you hit read, it will automatically output the new colors. So get some other colors going in there, and then get back the colors we like. The final thing I want to note about this is that you can, of course, have these colors load automatically when you turn on your patch just by connecting this main toggle through a button is the best way to do it. Toggle to a button to the read planet colors. So let's just save it and close it and see that work. So I'll open up the patch, and I get my city, and I already have my colors loaded, and I can jump to any one of my saved positions here. And I don't even need this jit.noise and jit.gen anymore. I could actually remove those because my colors are saved. But I'll leave it there just in case I want it as notes or want to study it again. So that actually is a good moment to bring up send and receive, because as you can see, Max becomes a mess of patch cables. There are multiple ways to send wireless connections, and the simplest one is the send object and the receive object. So if I say send start, anything I send into the send start object, like for instance the toggle, will come out of the receive start object. So now these two toggles are synchronized, send and receive. That enables me to have things happen by remote control. So when I turn on the patch, this toggle, the one of this toggle turning on, will be sent to the named address start, and over here it'll be received at the name address start and read in my planet colors. What you really want to do is use color here. You want your send and receive objects to have the same color in the bar so that you can easily find send and receive pairs on the screen. So here we have 4 things going into this inlet. This is a perfect, we have 5 things actually going into this inlet. This is a perfect place to do a receive poly fizz. Hook it into that inlet, and then send poly fizz. We'll just take everything that's going to poly fizz and connect it to a send poly fizz object. So these patch cords that are stretching all across the screen now are replaced by send and receive pairs, and things are much cleaner. And you can go through your whole patch and use sends and receives so that you have less patch cord clutter. You can also put sends inside of encapsulations. So for instance, I can de-encapsulate building position here and re-encapsulate it with poly fizz in my encapsulation. And now when I open up building pos, my send is inside there, so I no longer need any patch cord coming out of here. this send is a wireless connection to this receive. And as I've said, color coding is very important. So I'm going to go through and color code all the send and receive polyfizz objects. And I should also color code the one that's inside here. And you may want to remove other color coding so that it doesn't get confusing. The next step is going to be to work on a little bit of lighting. Let's make a jit.gl.light type spot position. We'll put it off to the side and above. We'll put it like 10 meters to the right, 10 meters above, and maybe 5 meters towards the camera, looking at the center. It's got a very hard edge spot. That's cool and that's dramatic. We can give it a little bit of spot fall off. There, that's a nice softer edged spotlight. So now our city has a much more dramatic illumination. The problem is our planet doesn't have any illumination. So let's make another spotlight, and we can put it in the same location, but this one will have it look at our sphere. The problem is, where is our sphere? Our sphere is now movable. But just like we can say position 1, 2, 3, $1, $2, $3, we can also say look at $1, $2, $3, and use the same multi-slider to control the position of the planet and what the light is looking at. We can actually use either one of these lights. We'll just use the top one here. So now we've pointed our light directly at our sphere by telling this light, because it's a spotlight, to look at the planet. So the planet, wherever it moves, it's not much of a planet because it's right over a city, but if we put it over here on the horizon more and maybe tilt our camera down a bit. There. Now it's more like a planet up there in the sky. Our spotlight is following the planet so it remains illuminated. Right now our sky is not very interesting. You can actually send an image directly into jit.world. So if I say jit.noise 1 float 32 1000 by 1000, I can send that into my jit.world, and it's going to make a random noise sky image for me. Now that's not a great sky. That's static. I mean, that might be cool for some application, but static sky is not what we want, and it's not filling the background very nicely. So we need a new attribute of jit.world, which is preserve_aspect 0. So with preserve_aspect 0, our static will now fill the sky, and that's nice, but still we don't want a static sky. But this is very easy to convert into some stars. If we say jit.gen one of the things we can use in jit.gen is greater than and less than. And greater than and less than return a 1 if they're true and a 0 if they're false. So we can look at these random numbers and say, hey, are you greater than 0.99? And if they are, they'll come back as 1, which in this case will show up as white. And if they're not, they'll come back as 0, which will show up as black. So that's an instant starry sky generator. And those stars are pretty dense. We can even say greater than 0.999. And that's going to give us a sparser, starry sky. So it's just a quick trick for generating stars. And we can connect this right up to receive start so that our starry sky is generated every time we start the patch. And we're going to look much more at greater than and less than. This is just a simple introduction to it. Basically what it's saying is, because these are random values, 1 in every 1,000 dots will be white. And also, you see how we use jit.noise1 here, because jit.world is helping us by automatically interpreting a one-plane image as a black and white image. Ordinarily, we'd have to put the red, green, and blue equal to the same value to create shades of gray. Here, we're creating shades of gray simply by specifying that it's a one-plane jit.noise. And it's going to give us, every time we click this, it'll give us a different arrangement of stars. So now we're really getting someplace, right? We've got this dramatically lit, randomizable city. We've got a randomizable planet, but we've also got a way to save a particular set of stripes on the planet. And you could use this to save a particular arrangement within the city if you wanted to as well. The last step in this is we want to be able to move things. We want to be able to animate things. To do that, we're just going to look at a new object, which is pattern storage, and which takes a name. We'll call it params, or call it whatever you want. Doesn't matter. It's in all caps. Pattern storage params, and it needs along with it an auto pattern. And these will autocomplete for you if you just start typing them. Pattern storage params, auto pattern. This allows us to take any user interface object, of which we currently only have one, our multi-slider, and save that into a file that's part of our project. So the way we do that is we use a new object called attrui, A-T-T-R-U-I, connect that to the object we want to save, lock the patch, click it, and select scripting name right here, scripting name, and it's going to show up as var name. And var name is what this stored multi-slider is going to be called in our pattern storage. So we'll call it planet position, planet pos. And now if we double click our pattern storage, we'll see we have a slot for planet pos. And we can then use this to store cues. So we make a message and say store 1, and click it, and now this is stored as position 1. We'll move the planet, and we'll say store 2. And to recall them, we simply send that number. So to go back to position 1, I click 1. Now our planet is moved back to position 1. To go to position 2, I click 2. Now our planet is moved to position 2. And that's all well and good, but we want it to move between those two locations. So how do we do that? That's our last new object, which is line, which takes 2 arguments, which you can just always use 0 point space 20. And then a message that is starting queue, comma, ending queue, space, amount of time. So starting queue of 1, comma, ending queue of 2, and then amount of time expressed in milliseconds or thousandths of a second. So if you want this to take 5 seconds, you say 5,000. 1, comma, 2, 5,000 will cause it to go from Q1 to Q2 over 5 seconds. And there it goes. And if you want it to go back, you say 2, comma, 1, 5,000. From Q2 to Q1 over 5 seconds. So now we have motion in our patch. The last thing we need to do here is to save this pattern storage. We do so the same way we did by saving a matrix. We send a write message, and it will write params, And we don't want to write it into the patchers folder. We want to write it into the data folder, which we don't have a data folder right now. So it will create one for us. So for right now, we can save it in params into the patchers folder. And take the read message to read it back in. And it's the params.json in the patchers folder. But if we cancel this, save our project, close our project, open our project back up, and look at the project structure, we'll see that it has created a data folder, and it's put our params and our planet colors into the data folder for us. So even though we saved it into the patchers folder, Max moved it into the data folder because that's where it belongs. So let's go back into our patch, turn it back on, and make sure we can get everything back. Can we get back our random city? Yes. Our lights are working. We automatically got back our colors because we had receive start connect to read planet colors. Our pattern storage also looks like it automatically loaded up for us, so we didn't even need to read it. It found it in the data folder, so that's great. Let's take another attribute. Let's take, for instance, the rotation of our buildings. So I'm going to use my snippet here. Multi-slider, 3 sliders. It made me a new one. Here it is. And I'm going to use it to rotate all the buildings. So I'm going to say target 0, rotate XYZ, $1, $2, $3, and send that into the physics input of my poly. And now I can rotate all my buildings with an interactive control. They're not rotating very far though. Why is that? Well, that's because my range of this multi-slider is set to, we can look at what it's set to by clicking on the eye here. It's set to -10 to 10. So that's only a 20-degree range. And of course, there's 360 degrees in a circle. So we want a much bigger rotational range here. So we'll make a message, set min-max, -180 to 180. Now we're going to get the whole rotational range, 360 degrees, on the x-axis, the y-axis, and the z-axis. And that's pretty hip. Get a lot of different stuff going on there. And of course, we're going to want to potentially save this as well. Going to bring back to 0. So in order to save it, it needs to have a var name also. So we can just take this attr UI that we've created here, make a little space for ourselves, and connect this attr UI to this multi-slider and call it BLDG rotation. And we'll see immediately in our pattern storage a building rotation line has been created for us. So now we can save rotations into our queues. So if we go back here to queue number 1, change the building rotation, and store 1 again. Then go to queue number 2, change the building rotation, and store number 2 again. Go back to queue 1, and now when we go from 1 to 2, our planet's going to move and our building rotation is going to change. And of course, we can add additional queues. So store 3 is going to store a third queue. And we can make another message here to go from Q2 to Q3 over another 5 seconds, say. And in Q3, we can have some other rotation and some other position for the planet if we want. So store that as 3. Go back to Q2. Now travel from Q2 to Q3. So now we're really animating.